So 5.3 is a continuation of what we've been doing in 5.1 and 5.2. We're still dealing with our triangles, but now we're going to talk about them in standard position, so in a coordinate plane. So theta always comes from the center of the circle. So I would note that theta comes from the center, or center of our coordinate plane. So since theta is the angle here at the center, we're going to have values x, y, and r. So y is on our y-axis, and when we go up, that would be our y. When we go on the x-axis, that is our x value. And then r, bless you, is our hypotenuse. Another thing to note is that r is always positive. Now we're still going to be finding our trig functions just in a coordinate plane, so in standard position. So with our theta here, we're still using SOHCAHTOA, but it just is kind of a little different here. With sine, we know that sine's opposite over hypotenuse. So what would our opposite be here? Y. And what's our hypotenuse? R. So sine would be y over r. Cosine is adjacent over hypotenuse. So what's our adjacent? X. So it would be x over r. And then tangent is opposite over adjacent. So what would that be? Y over x. So these you have to know. The reciprocal functions are just going to be the flips of them. But if you forget which one's which, you can always just draw your triangle in standard form and know that sine, as long as you know sine is opposite over hypotenuse, you could figure these out. So our three trig functions, what we just wrote, are on the next page. Usually x and y are going to be given, and you'll have to find r. So we would use this formula. Now, looking back on that last triangle, when we have a triangle in our standard position, if it gives us x and y, how do you think we could find the hypotenuse of the triangle? Pythagorean theorem, which is essentially this formula. It just, instead of the c squared or r squared here, it took the square root to move it already. So you can use this formula, or you can use Pythagorean theorem. And then here's all 6 of our trig functions in terms of x, y, and r. Also, depending on which quadrant we're in, so our triangle won't always be in the first quadrant. We could have a triangle that comes from the second quadrant here. Depending on which triangle we are in depends on the sign of theta, or of our trig functions. So we have an acronym here that stands for all students take calculus, or all are positive. Sine is positive, tangent is positive, and cosine is positive. So these tell you which quadrant which trig function is positive in. In the first quadrant, all of our trig functions are positive. In the second quadrant, the one that has S, just sine and its reciprocal are positive. So sine and CSC, cosecant. In the third quadrant, just tangent is positive. Tangent and its reciprocal, cotangent. And then in the fourth quadrant, cosine and its reciprocal, secant, are positive. So starting in the first quadrant is all, and then you just go around your quadrants from there. So all students take calculus. So on the next page, we have to determine which quadrant we're in. So I think it's helpful to label your acronym first. So we have all students take calculus. Now it says sine is less than 0. So that means sine is negative. Which two quadrants can we eliminate knowing that sine is negative? It's not going to be in the all positive one. Which other one is it not going to be in? The sine. Because in sine has to be positive. But here it's negative. And then we also know that tangent is greater than 0, so that means that it's positive. In which of the quadrants left is tangent positive? Tangent. So which quadrant would we be in? 1, 2, 3, or 4? 3. Perfect, because this is 1, 2, 3, and 4. So we are in quadrant 3. So you could say Q3. Let's do the same thing for the next one. So I'm going to label my quadrants here. We have all students take calculus. Secant goes with which trig function? Cosine. So it says cosine is greater than, or secant is greater than 0. But we know that means that cosine is greater than 0 too. So cosine is positive if it's greater than 0. So which two quadrants can we eliminate knowing that cosine has to be positive? Tangent and sine. Because cosine being positive is only positive and all is positive and cosine positive. This one should be CSC. But which trig function goes with cosecant? Sine. So sine is less than 0, which means that it's negative. So which quadrant are we talking about that sine is negative in? C. So we'd eliminate A, because it's not going to be all positive if sine is negative. Which quadrant are we in for C? Quadrant 4. All right, in our next example, we have to determine the 6 trig functions. So here we're given that tangent is negative 5/3. And theta's in quadrant 4. So I'm going to draw it. So theta's in quadrant 4. So we know that we have a triangle over here in quadrant 4. You always draw your triangle by dropping the edge towards the x-axis. Theta comes from the center, so it's going to be here. Now tangent is what over what? Opposite over adjacent. So I'm going to ignore the negative for now, but my opposite of theta is going to be 5, and my adjacent is going to be 3. Now, does the negative go with the 5 or with the 3, looking at where we are on the coordinate plane? The 5, because we went down on the y-axis, so that means the y is negative. Now, how do we find the hypotenuse? Pythagorean theorem. We could do 3 squared plus negative 5 squared is equal to, we'll call it h squared. So 9 plus 25 is equal to h squared. This would be 34 is equal to h squared. Take the square root. So our hypotenuse is the square root of 34. So now that we've labeled everything on our triangle, let's find our 6 trig functions. So you're going to find sine of theta, cosine of theta. Tangent of theta is already given, so that one's going to be easy. And the reciprocals, so cosecant, secant, and cotangent. So with these questions, I think it's super helpful to draw the triangle, because then you don't have to really remember that sine is y over r. You can just look at your triangle, and you know that sine is opposite over adjacent, because we know SOHCAHTOA. So So what's our opposite of theta? -5. So we have -5 over square root 34. Can we leave this as an answer on our quiz? No. What do we have to do? Rationalize. So we multiply the top and the bottom by square root 34. So we get -5 square root 34 over 34. Next, cosine. Cosine is adjacent over hypotenuse. What's our adjacent? 3. So it'd be 3 over square root 34. Again, we have to rationalize, so we're going to multiply the top and the bottom by square root 34. So we get 3 square root 34 over 34. And then tangent is opposite over adjacent, but tangent was given to us in the beginning. What's tangent? -5 over 3. Now let's find our reciprocal functions. So cosecant, we just flip sign. So I flip sign before I rationalize. So we get square root 34 over -5. Secant, we flip cosine before we rationalize. So square root 34 over 3. And cotangent, we flip tangent. So 3 over -5. So these would be our 6 trig functions. The last thing I would recommend to do is always check your signs. So we're in the 4th quadrant. So we have all students take calculus. Only sine and its reciprocal should be positive. Everything else should be negative. So only cosine and its reciprocal. Is that what I said? So sine and its reciprocal are negative. We're good there. Cosine's positive, which we know cosine should be positive in the 4th quadrant. And tangent is negative. So we're good there. I would just always double check your signs, especially on a test or quiz. Last thing you do, just go through, make sure in the 4th quadrant, only cosine and its reciprocal should be the positive ones. Everything else is negative. All right, ready for the next one? So here we have secant of theta is -2. And theta is in quadrant 3. So let's draw our triangle. And we're in quadrant 3. So 1, 2, 3 would be down here. Now when you draw your triangle, you always go from the line to the x-axis. So you always drop it to the horizontal axis there. And theta always comes from the center. Now secant goes with which trig function? Cosine. And cosine is what over what? Adjacent over hypotenuse. So that means secant's going to be the opposite. Well, or the reciprocal. We have -2. How do we turn that into a fraction to make it over something? -2 over 1. So instead of it being cosine is adjacent over hypotenuse, we have hypotenuse over adjacent. Now remember on the first slide when I said that r can never be negative, our hypotenuse can never be negative, so that negative actually goes with the 1. So when we draw that, what's adjacent? Looking at our triangle here, what would be adjacent to theta, the x or the y? The x. So here we'd be -1. So which makes sense because we went to the left in the negative direction on the x-axis. Our hypotenuse is 2. Our hypotenuse can never be negative. Now, how do we find the missing side? How do we find our opposite? How do we find the opposite? Pythagorean theorem. So we have -1 squared plus, we can call it x squared, is equal to 2 squared. So 1 plus x squared is equal to 4. Subtract 1. X squared is equal to 3. Take the square root. So our opposite is square root 3. Now, always double check your signs. Am I going up in the positive direction or down in the negative direction for my y? Down. So it should be negative square root 3. So once we have everything on our triangle labeled, let's find our 6 trig functions. Sine, cosine, tangent, and their reciprocals. Cosecant, secant, and cotangent. Any questions so far? All right, so it helps to know SOHCAHTOA. So sine would be opposite over hypotenuse. So what would that be? Negative square root 3 over 2. Perfect. We don't have to rationalize because the square root's on top. Cosine would be adjacent over hypotenuse. So negative 1 over 2. And tangent would be opposite over adjacent. So negative square root 3 over negative 1, which simplifies to what? Positive square root 3. Now let's find our reciprocal function. So cosecant, we're going to flip signs. We get 2 over negative square root 3. We have to rationalize, so multiply the top and the bottom by square root 3. So we get 2 square root 3 over negative 3. Secant was already given to us in the beginning. We flip cosine, so it would be negative 2. And then cotangent is the reciprocal of tangent, so it would be 1 over square root 3. We have to rationalize, so we multiply the top and the bottom by square root 3. So square root 3 over 3. Now, last thing we always want to check is our signs. We have all students take calculus. So in the third quadrant, only tangent and its reciprocal should be positive. So tangent's positive and cotangent's positive, so we're good there. Everything else should be negative. So our sine's negative, cosine's negative, secant's negative, and cosecant's negative. So checking your signs at the end is helpful in case you missed that when you go down here, your square root 3 should be negative. So it's just a good way of double checking that you did your work right. If not, you got to fix the signs at the end.